Hey BioTeam. So you guys have learned that enzymes are more effective at breaking down and synthesizing substrates in certain conditions. There are some conditions in which they're really effective, and there are other conditions in which they are inactive or they become denatured and are completely ineffective. This video tackles how biologists determine the ideal conditions for an enzyme. For example, how did biologists determine that this particular enzyme is most effective at a pH between 6 and 8? Well, to determine where an enzyme is most active, biologists measure the rate at which an enzyme's reaction occurs. That is, they'll look at the molecules made in the reaction or consumed in the enzyme's reaction over a given period of time. So there's a couple of ways to measure the rate at which a reaction occurs. The most straightforward of which is to measure the rate at which product molecules of the reaction get made. Or the opposite, to measure how quickly the reactant molecules in the enzyme are consumed. And in an enzyme reaction, this would be the substrate molecules. But whether measuring products produced or substrates consumed, most scientists will look at the initial rate of the reaction. That is, they'll look at the rate near the beginning of the reaction rather than the rate near the end of the reaction, because for most enzyme reactions, the rate near the end of a reaction will approach 0. And this is just because the molecules involved in the reaction, the reactant molecules, start to run out as they all get converted to products. But biologists can measure the rate of reactions indirectly too. For instance, the progress of some enzyme reactions can be measured with indicators. That is, chemicals that change color over the course of a reaction. And so the more effective an enzyme is at speeding along a reaction, the more quickly a color change associated with that reaction will occur. And you can kind of see the various stages of a given reaction over here. You can watch as the color changes from the beginning of the reaction to the end of the reaction over time. As for how scientists measure the change in color quantitatively, that is, rather than just describing the color change, actually measuring with numbers how much color has changed, they can look at the absorbance of a substance, that is, how much light a substance absorbs, where the darker the color, the more light it absorbs. Or they can look at the transmittance of a substance, that is, how much light a substance allows to pass through. And so as some reactions progress, the molecules involved will absorb more light or transmit more light as the reaction goes on. And so in this case, you can see that as this reaction went forward, the molecules involved allowed more light to transmit through, and they absorbed less light the more the reaction progressed. And there are other ways that scientists can measure reaction rates too. Because lots of reactions cause visible side effects to occur, scientists can time how long it takes these effects to occur. So one example of this, scientists can measure the rate of photosynthesis reactions inside of leaves by sinking leaves to the bottom of a solution and then timing how long it takes the photosynthesis reactions to produce enough gas for the leaves to float. And so this is just one specific example, but what's worth emphasizing here is that scientists can get really creative in timing reactions. Depending on what the reaction is, there might be different visible side effects that scientists can time. But that's it. At this point, you guys have some practice problems. We'll see you next class.